Okay, so this is arc lengths and areas of sectors. These the portion of the circle, like these are called sectors. Okay, and arc length is the portion of the circumference of the circle that is cut off by these are not chords, these are radius. Okay, so it's always a radius. It starts from the center. Okay, that's the arc length, and that's called a sector. So area of the sector and arc length is this section. So this is just the basic ones, and you can kind of guess or use an educated deduction how to get to these areas. So let's just go over this. Okay, so if this is 90 degree, you know that there are 4 of these, right? So if the area of this so can you find the area of shaded regions? If the area of this circle, the radius is 1, so area is pi r square. So that's pi 1 square, which is pi, right? And that's quarter of it. So this area of a sector is pi over 4 units square. Okay? And for this one, if this is 120, the arc measure of arc is 120, then this is 120. And then that means there are 3 of these, right? So then the area should be 1/3, right? This area should be the quarter, this should be 1/3. And the area of this circle with radius 6 would be pi r square, so that's pi 6 square. So that means 36 pi. And you want 1/3. So area is 36 pi over 3, which is 12 pi units squared. Okay, so I want you to try these for homework using the same logic. I think you can do this. Okay, all right, let's start over here. And we are 11:6. We are not doing this. This section's a little tricky, but these 2 are not bad, okay? I don't think they are bad. So the objective for this section is know and use the formulas or formulae for arc, length, and the areas of sectors of a circle. Okay, so that's the objective. Length of arc and area of a sector, we kind of went over this in warm-up. You get the idea. Formula for arc length and area of sector. In general, if measure of arc AB is x, then the length of arc AB is x over 360 times pi 2 pi r. What this means is that if this is x, right? And if you do x over 360, you get the fraction of this. So for example, if I did, this is 90, right? So 90 over 360 will give you a quarter, right? And this is 120. 120 over 360 will give you a third, and that's what we use to divide this, right? So that's what this is. This will give you the portion or fraction or percentage of the circle that this sector represents times the whole circle circumference length, which is 2 pi r. So this is the whole circle length, and you're just applying a portion of it to get to this arc. The same thing, the whole area is pi r square, and by multiplying by x over 360, we're just getting the portion of the circle's areas. That's all there is to it. That's really the concept. And there's a different formula that you learn in pre-calc, but using radian, but we don't have to worry about that right now. So only thing we have to know is to get the arc length and the area of a sector, we're just going to calculate what percentage of the whole circle this area represents, and then take the whole area, multiply by the portion, and then you get it. Okay, so okay, let's go over this example quickly. Okay, in a circle of radius 9, measure of arc AOB is 120. Find the length of the arc AB and ABC and area of two sectors shown, this area and this area. Okay, so arc AB is 120, then the other side is 240, right? ACB is 240, so the minor arc AB, the length of arc AB is 120 over 360, which will give you, this is the third of a whole circle, 2 pi r to get the circumference of the whole circle. So it's a 1/3 of 18 pi, which is 6 pi. The area of sector AOB would be this area, right? So it's 120 over 360 times pi r square. So that's 1/3 of 81 pi, which is 27 pi. And for the major arc side, you do 240 over 360. So it's a 2/3 over 18 pi, that's 12 pi. And the area of sector is 240 over 360, pi r squared, 2/3 of 81 pi, 54 pi. Units are missing here, obviously. So this is just the unit. This is unit square, this is unit, and this is unit square. Okay, area and length. Okay, example 2. Find the area of a shaded region bound by the chord xy and arc xy. So how do we do this one? You get the area of a sector, and then you get the area of a triangle and subtract it. So since this is 90 degree, 90 over 360 will give you a quarter. Or if you know it's 90 degree, you know it's a quarter over whole circle. So the area of a sector is quarter of area, right? Area, yeah. So pi r square. So it's quarter of pi 10 square. So that is a quarter of 100 pi, which is 25 pi, right? And the area of a triangle is, this is the base and this is height. So 10 times 10 times 1/2. So that's 100 times 1/2, which is 50. So 25 pi minus 50 units squared would be the area for that one. Okay? All right. So that's it for the instruction part. The rest is exercises. So I want you to do odds here. We're going to do this now in the video. Okay, I'm just going to assign the problems. And then sector AOB is described by giving measure of arc AOB and the radius of circle O. Make a sketch and find the length AB and the area of sector for AOB. Okay, so I think these are not interesting, I don't think. So let's do these. Okay. So do these for homework, and we're gonna do these in the video. Okay. Alrighty, and then let's see. The area of sector AOB is 10 pi, and circle AOB, find the radius of a circle. Alright, try this for homework. Okay, and we can do this in the video. And oh, that was it. That's it. Oh, actually 2 more pages here. All right, so I'm gonna send one of these for video survey. Okay, and then we do the rest in the class. Okay, so that's the plan. And so let's start with 6. A circle has area of 160 pi centimeters squared. If a sector of a circle has area of 40 pi centimeters, find the measure of arc of the sector. Okay, so the whole thing is 160 pi square centimeters, and the sector has 40. Actually, that's a quarter. So, oh, that's it. That's 40 pi. So 40 pi over 160 pi is a quarter. By the way, when you are taking the ratios, like say this is centimeter square and centimeter square, these things all cancels, you know. The ratio doesn't have any unit, because ratio by definition is comparing two numbers. So this one doesn't have any unit. So if you wrote like centimeter squared or centimeter or something, you lost a point because you got the unit wrong. Okay, so this area is a quarter, and therefore the measure of the arc of the sector is 90 degrees. Okay, and let's do 8. Sector AOB is described by measure of arc AOB and radius O. Okay, so 360 and radius of 6/5. Okay, so 320 would be, this would be 30, right? No, wait, 40. This would be 40, and this would be 320, right? Oops, you can't see. All right, so you are doing 320 over 360 times 6/5 squared times pi. Are we doing the area? Yeah, area. Okay, so you do this, and so if you simplify, well, are we supposed to do a sector too? Find the length of AB. Okay, all right, so then it's also 320 over 360 times 2 pi r. 2 pi r. R is 6/5. Yeah. Okay. So this one, what is this? 8/9, right? 8/9. 8/9 times 6 times 6 times 5 times 5 pi. Okay, so nothing cancels here, but here, this is 3 and 3, and there is a 3 and 2, 3 and 2, so 3 and 3 cancels, and what's left is 4. So that's 4 times 8 is 32, 25 times 1, right? So 25 pi. Okay, and there is no unit here, so that's unit squared because this is the area. And the sector is the length, so the unit is just the unit. Okay, so that's 8/9 times 12, no, it's not 10, sorry, it's a 5. This is a 5. Okay, so this is 3 and 3, and 12 is 3 and 4, and 5 and 8 doesn't cancel. So 3 and 3 cancels. So what's left is 3 times 5 is 15, and 8 times 4 is 32 pi unit. Okay, so that was 8. Okay, see, if I do it this way, I didn't have to use a calculator at all because I'm canceling before multiplying. Okay, let's do 10. So 10 is 192, so it's a little less than 200. So that means it's a little bit over 180 degrees. It's something like that. Okay, all right, so it's 10. 192 over 360 times the radius is 3√3 squared pi. So this would be the area. Okay, so let's see what this cancels too. 180 over what? 96? 90 over 48, 45 over 24, 15 over 8. Is that it? Probably. All right, so let's try this. It's possible I made a mistake, but let's see. 2 square of 3 is 9 times square of square root of 3 is 3, so that's 27 pi. So this is 5 and 3, so the 3 cancels. And so you got 72 over 5 pi. And unit square. Yeah, that looks right. And the sector is, so 8/15, because we know now A15 is correct. 192 over 316. 360 is A15 times 2 times this, so that's 6 root 3 times pi. So so this is 3 and 5, and this is 3 and 2. So 3 and 3 cancels, and so denominator is 5. And this 2 root 3 times 8 is a 16 root 3 pi and unit. Now pi you can put in the numerator. That's also correct. You can put it outside or inside the numerator. Either way is correct. You know that, right? Okay. Let's see what else we said we're gonna do. We're gonna do this one. The area of sector A or B is 7 pi over 2, and measure bango A or B is 315. Find the radius of a circle. Okay. Alrighty. So whatever this is, oh, measure of arc A or B is 315. So it's something kind of like this, right? And this is 7 pi over 2. So 315 over 360 times radius times pi is 7 pi over 2. Oh, sorry, this is area. Yeah. So radius square times pi is that. Okay. So let's simplify this one first. So if you divide by 5, you get 63 over 72. Can you divide this by 3? Yeah. So that's 21 over 24. Is that it? Yeah. And that means 7 over 8. That's 7 over 8. Okay. And so 7 over, and then don't you do this, okay? Because this does not equal. Many people do that, and really I dislike it. Okay, you equal have to be equal. You cannot add things, then it's no longer equal. I will deduct a point if you do that. So you have to write 7/8 again. R square pi is 7 over 2 pi. Okay, so you want to isolate the R square, right? So first, just to get rid of pi on both sides, you divide both sides by pi, and you get 7 over R square is 7 over 2. So R square is 7 over 2 times 8 over 7, right? Flip it. 7 cancels, and this is 4. So that's 4. That means R is 2. Since it's a length, we don't have to worry about negative. So radius is 2 unit. It's a length, so you don't need a square. Okay? That's it. I'm going to assign one of these for survey.